Matin Mavaddat is an experienced technology professional with over 2 decades of industry expertise. He holds advanced degrees and roles from software engineer to principal security engineer. He contributes through work, publications, and patents. As the principal security engineer at Amazon since 2021, Mateen has developed innovative security solutions for healthcare driven by collaboration, continuous learning, and leveraging technology for meaningful impact. Mateen joins us to explore a definition of security that will have you pondering when you try to go to sleep tonight. He helps us understand the systemic nature of security and the role of the anti requirement. I've been doing this podcast for 7+ years at this point, and this is one of the interviews that really left me thinking and reconsidering a lot of the things I understand about security.
Today's episode is brought to you by Security Journey. Our education platform teaches valuable secure coding skills based on real-world vulnerabilities and threats, including OWASP Top 10. Learn more at securityjourney.com.
Hey folks, welcome to this episode of the Application Security Podcast. This is Chris Romeo. I am the CEO of Davici. We are the threat modeling company / platform. And as always, joined by my good friend, Robert Hurlbut. Hey, Robert.
Hey, Chris. Yeah, Robert Hurlbut. I'm a principal application security architect and threat modeling lead at Acquia. And as you said, glad to be here again to talk about AppSec.
I think we're going to go in a slightly different direction than we've ever gone before.
Yes.
And so I'm excited to have Mateen join us here. And Mateen, we always like to jump right in with guests' security origin stories, giving you no time to warm up. We just throw you right into the deep end of the pool. But how did you get started in security?
Thanks, Chris. Thanks for having me. Well, it's a very good question. Actually, I started my both academic and professional career in computer science and software engineering. Initially, actually, as a requirements engineer, working as a business analyst for a few years, and then became systems architect. In 2015, I started working for a bank, and there I realized there was this huge gap in the way that we're doing actually security there. So I started actually delving deep in the concept and kind of trying to become more and more knowledgeable about security. And basically, I just started my journey there. The question I've always had in my head, that I was trying to find an answer, was that why are we always sort of behind in security? Why are we always kind of cannot kind of achieve all the objectives that we wanted to achieve compared to other disciplines in the kind of computer science and wider discipline, if you like. And I was talking to different people, different experts at the time, some people giving me like these interesting notions, for instance, like the fox runs for itself, the hogs for their owners, something like that, or the asymmetry between defense and offense, and especially in cybersecurity, basically we have to fix all the problems, but hackers just need to find one, and they can. There's a little bit of kind of truth in all of that, but never kind of satisfied with these kind of answers. And also, talking about the complexity of the problem, although I'm not really sure that everyone understands the kind of complexity. But anyway, so I was hearing a lot of perspectives, but none of them was kind of giving me the answer. I was thinking it was that there should be more kind of foundational problem with the way we do security. And then that was the start of the journey, actually.
Mm-hmm. So one follow-up question. I read the article that is the basis for some of what we're going to talk about. We'll put that in the show notes for folks to see the original source. But my question for you is, has philosophy been something that's in your past? Have you studied philosophy?
Well, having academically studied philosophy, but I've always been very interested. So I've been kind of reading books, articles. Been at this part of my doctoral research. I've been kind of quite familiar with John Searle's kind of research, because speech act, all those kind of things. Because what I was trying to do at the time was to extract business processes from conversation logs or from transcribed kind of conversation logs. So it was a combination of speech AI, this is 2013. We didn't have many kind of advanced tools and techniques to read. Well, the foundations were there, but we didn't have all the huge computational power that we have today and the amount of data we have today. So just, that was my kind of interaction with philosophy. And I've always been interested since I was in high school reading stuff.
Cool. All right, so Robert, let's jump into it. Okay, so you mentioned you were at the bank and you were noticing some things about security, but let's dive into what is your definition of security?
Okay, great. So this is actually, as I mentioned, like I was not satisfied with those kind of perspectives. So my kind of understanding at the time was that probably we don't fully grasp the concept, don't really understand what we're dealing here. Basically, I thought that we were kind of suffering from two kinds of fallacies. One that we could call I or ED, basically familiarity. We would confuse familiarity with understanding of the concept. And the other was like they were confusing manifestations of a phenomena with itself. Let me explain what I mean. Like, whoever you ask, do you understand life? They would tell you, of course, they would tell you, of course, and they can easily tell, they can easily tell if something is a lie or not. But usually when you delve deeper, when you just actually then tell them, okay, so can you actually define life? What is life? What is a living being? It would be very difficult for people to come up with precise definition. And they usually confuse, and they usually say they understand because they're familiar. They hear it everywhere, they see it everywhere. They confuse this kind of familiarity with understanding. And the other thing is they confuse manifestations of life with life itself. So for instance, if you ask someone, okay, how would you say if someone is alive? So, okay, so if they're talking, if they have a pulse, if they have like temperature, they're alive. But then you know that something can have all of those manifestations and be completely dead, right? So you would never actually ask a non-expert to tell if someone who is on a kind of hospital bed is alive or not, because you don't want someone with that kind of notion to make a decision about life, right? But even experts or so-called experts make kind of mistakes about life. This is so hasn't been very well kind of understood or defined. So I started this is also starting in my kind of prior work on requirements engineering, because, as a business analyst, my kind of role was to go and understand the requirements and kind of try to elicit those requirements and help the businesses build system based on those requirements. And I remember at the time we would divide requirements into functional requirements and non-functional requirements. I don't agree with that kind of division at the moment. I think there's a third type, which I call anti-requirements. But security was called a non-functional requirement. A non-functional requirement is basically quality. It's called the quality of the system. So there is some things that are behavior of the system and things that are qualities of the system. And the most important thing about the quality of the system is that it's holistic. You cannot attribute the quality to any specific part. It's kind of created from the interaction of the parts. So these are called, I'm sure that you've heard of it, it's called emergent properties of the system. The qualities of the system, and some of actually the behaviors as well. I don't want to discuss, but most of the qualities are emergent properties. So we think of security as a non-functional quality of the system. It means that it's holistic. And it has some very, very interesting characteristics. So emergent properties have very interesting characteristics. One of them is you cannot measure them directly. So there's no way that you can measure an emergent property directly. Just like, life is an emergent property of a living being. That's why we cannot actually have a measurement, but we can only understand it through its manifestation. So we can come up with metrics or things that kind of tell you if something is alive. But having those manifestations does not necessarily mean that they're alive. Correct in one way, it's not the other way. It makes it possible to fake them. Okay, so that's why you can easily have security theater, and that's what they were.
Is this, Mateen, can I give you a quick example? Let me just to make sure I'm tracking with you. So let me give you the example of, I scan a system, it doesn't have any, the scanner returns no vulnerabilities. So I say, hence this is secure. But what you're saying is, in fact, that's not the case. It was the tool. We're not doubting the results of the tool, but it's not just the results of the tool that provide the overall answer. Am I tracking with you?
Correct. So basically it means if a system is secure, it won't have any vulnerabilities.
Okay.
But if a system does not have any vulnerability, it doesn't mean that it is secure. So it doesn't go that way. So that's why it makes it, that asymmetry makes it very difficult.
Okay.
So, and you can have it in many different kinds of emergent properties as well. Going back to life, if you're alive, you have a temperature, your pulse. But the thing that is a pulse and temperature is not necessarily alive. And that asymmetry is very, very important.
Is there, like, what would you say? So like a plant would be an example of, just trying to pull on this thread of this example. So technically a plant doesn't have a pulse, I don't think. Doesn't have a heart, as far as I know. Most of them don't. Maybe there's one somewhere. And so, but we know that a plant is alive. So we can't say that you like breathe. But technically, I guess plants don't breathe air; they breathe CO2. So it's so basically that's what your point is here, is like the plant is alive, but it doesn't meet the same criteria as the human beings definition.
Well, that's a little bit different, actually. So it depends on how you define life. So in work, we define life differently, but this is a little bit different. This is like, if you come up with the metrics to measure life, I can go and fake them in a way that you can think something is alive, although they're not. That's what I'm trying to say. So you can say, this is how I measure life, with pulse, with temperature, whatever. But I can go and build a robot, for instance, that it's not alive, doesn't have anything, when it has a temperature, a pulse and everything, but still not alive. That is symmetrical. So that's the security theater that we talk about. So if your system is secure, it will show all those manifestations, but I can fake all those kind of metrics in a way that a completely insecure system shows all those manifestations that is actually not secure. That's what I'm trying to say. That's why we have security theater. And the third kind of characteristic of emergent properties, as also given more important, is that improving the parts from those characteristics perspective does not improve the whole. And usually it makes it even worse. So if you go and improve, this is like in security, it means if you go and improve your components from security perspective, whatever your understanding of security is, even if your understanding is correct, it doesn't mean that your whole system is now secure. And you can see that, and because security is coming from interactions of the part rather than the parts themselves. And you can see that in many different kind of, an example to prove that, for instance, is that, let's assume that we are building a car. I can go and find the best, most kind of performance pieces of the car from different manufacturers. Putting them together, you don't have a car. Because the most important thing about a car is how those parts work together, rather than how great each of those parts are.
I like that example. I'm just imagining a pile of parts on the ground. Like, hey, look at my cool sports car. And people are like, what?
Exactly. I see that in like other examples, like football teams that are made of stars, and they usually lose to local teams because they're great players in isolation, but together they cannot actually collaborate and work well. So that's another example I can do. And this applies to this concept of security as well. So having these two these kind of things. It seemed like security as a modern property, because of its properties, it has caused us a lot of problem. And our approaches, even now, doesn't seem to be fully correct. So we've been focusing on securing the parts. Wherever we kind of discuss things, people are talking about, oh, we need to encrypt things here. We need to, I don't know, just everything's focused on the part instead of the holistic picture, understanding what the system's trying to do and kind of enabling it to prevent undesirable states. When I was, so I started kind of, this is like 5-6 years ago that I've achieved this kind of systemic perspective for security, and they're actually talking about it. And I've had some pushbacks, which some of them are kind of interesting and actually have value and meaning. So some people are telling me, oh, so you're saying that fixing the XSS is not important? Are you telling me that, using a TLF that is not vulnerable is not important? Are you telling me that I don't need to scan for parts that have certain known vulnerabilities? And that's not absolutely, so we definitely should do that. But that's not what I'm focusing on. So I started actually creating 2 different concepts to answer both questions. So I started talking about syntactic security and semantic security. And please don't confuse semantic security with the concept semantic security in cryptography. This is a different kind of concept. So syntactic security is the thing that are always correct. So this is like the box, like I'm sure that if you've been an engineer, you fully understand what I'm trying. So it's like syntactic flaws versus semantics flaw, right? So syntactic flaws are the things that are incorrect. So your compiler really will compile if you have syntactic flaws. Your semantic flaws are the things that they're not incorrect necessarily, but they're incorrect in the context. So you need to understand fully what the context is, what the objectives of your system is, and then you can decide if it's a kind of semantics flaw or not, if it's ironic. The important thing about that is that if the semantic versus syntactic insecurity is a little bit different, but generally follows the same kind of pattern. So syntactic security are all things that are always incorrect. So you never want to have XSS. So you never want to have a vulnerable kind of component. And these are the things that we can automate. And these are the things that you don't need really much context to be able to identify. But the semantics security are the things that are very difficult to automate, and there are emergent properties. And that's the kind of systemic security that I am talking about, really. But then there's another kind of part to this as well. So now we have like syntactic security and semantic security. I started thinking about, whenever we talk about security, do we actually understand what security, even semantic security is? And I started looking at different people's definitions of security. And the most generic one that I found was security was kind of the degree to which it could prevent undesirable states. And this is the commonality between resilience and security, is that in security there should be a malicious intent. So you prevent all undesirable, if you can prevent all undesirable kind of states, of system moving to undesirable states, you have resilience. But so it seems like security is a subset of resilience when there is malicious intent. So when there's someone maliciously trying to move your system into the states that are undesirable. And at the time, I started thinking about, okay, so it seems that security is really not a thing. It does not exist. Because whenever we're talking about security, we're talking about an absence of something else. So, and that's when I started thinking about this absent existence phenomenon. or phenomena that is like in philosophy, there are kind of things that they do not have ontological, independent ontological existence. So they don't really exist in reality. So for instance, the example is like darkness. So darkness does not really exist independently. It's the absence of light, right? So the more light you have, the less darkness you have, and vice versa. So you cannot go and create darkness, you remove light. And there are many other examples that they have absent existence, but it's very important not to confuse a lot of other kind of concepts as absent existence. For instance, some people, they think war and peace are absent, and that's absolutely correct. War is not the absence of peace. War, they're completely different because they have independent existence.
Well, there's independent choices that drive it, right? Like darkness and light, there's no independent choice that drives it. It's just, it is. And I'm with you on that. Like darkness is the absence of light, but war is not the absence of peace. War is a choice by many different variables play into there.
Beautiful. Exactly. Just like hatred and love. Love is not the absent. But the important thing about the things that are not absent existent is that you need to put energy, as you mentioned, and decisions to make one possible, even if you remove the other one. But the good thing in security is that it's not actually, doesn't seem to be the case. It's like if you focus on removing those undesirable states or preventing your system to move to those undesirable states, you basically security emerges. That's the kind of emergence. So it's like, it doesn't have an independence. So you don't have to go and put energy into creating security. As long as you go and put energy to understand what those undesirable states are, and then build mechanisms or design your systems in a way that does not even have those undesirable kind of states, or there are controls that prevent the system to go into those kind of undesirable states. Yeah. And that's what I call an anti-requirement. So that's what that's why I think the focus on anti-requirements are important, because they're not really the opposite of the requirements. And the interesting bit about anti-requirements and requirements is that unlike the security and the security, they're not, anti-requirements are not absent existent. It doesn't mean that if you work on requirements, you automatically won't have anti-requirements. And I give you an example, like this genie in a bottle that we've heard a lot about in stories is like, you go and tell it what you want, but you don't tell it what you don't want. You just say, I want to be rich. And then what it does is that it goes and fill your house with pennies and with children. Because you want it to be rich. You didn't tell it that you're not, make me rich by, killing me or even, stealing whatever. Yeah. These are the anti-requirements. So the requirements, focusing on requirements does not prevent anti-requirements. We need to think in both terms from the outset. And this is kind of my way of kind of understanding shift left as well. So it's like, if you want to really shift left, it means that at the beginning, when you're working on a BRD, start thinking about what your system needs to do, as well as what your system should not absolutely do. And
so is that the definition of anti-requirement then? What your system should not do. So defining what it should not do.
Exactly. Absolutely. And so just like requirements in complex socio-technical systems, we have indefinite number of requirements. So we prioritize, right? The things that we want to build. The same with anti-requirements. We need to identify them and prioritize. I know that. And that's why absolute security is impossible. Because absolute security means knowing the absolute number of the anti-requirements. Anti-requirements are by nature in complex system indefinite. Because you don't know all the states that you don't want, or all the bad, undesirable behaviors system. As you don't know what the desirable behaviors are, and because it's so subjective and so context sensitive that with a small change in the context, so the anti-requirements become requirements. And that's the kind of, you've heard about like bug as a feature, right? So this is some sort of same concept. So in things that are anti-requirements in one system are absolute requirements in another. Even depending on how your context is changing, again, the same thing can happen. So even absolute security does not even, is axiomatically incorrect. So it doesn't even make sense because it's subjectively relevant.
Okay. So I'm going to ask you what I think of as the $1 million question now, which is, how do we make this, everything you just described, a reality in the average technology company out there? How do we take the things that you've unplugged and unpacked here and make them work in a resource-constrained environment where they're not going to agree that security is the absence of vulnerabilities?
I think it's not actually that difficult in my opinion, because we've learned how to focus on requirements. The message that I have is that if from the outset, as we're building this, as we're designing this, as we're thinking about the system that we're trying to build, and this is not just software, it's a system, the whole thing, including your operations, your people, everything is a socio-technical system that you're trying to build to realize some business objective. Start about the things that you definitely want the system to prevent. Because without that thinking, you won't prevent them. The interesting thing about systems are that they do what you designed them for. And if you don't take into consideration the things that you don't want them to do, they will definitely do them. Or in most cases, it will do them. So it's not really a very technical concept. It's not really, doesn't need a lot of expertise. As you just get together in a room, discussing your requirements. Again, I've been a business analyst for a few years. I know this is it's not a very difficult thing. Just bring people together and discuss it. I think start thinking about, okay, so I want this system to have this behavior. What are the things that I definitely don't want it to realize? What are the things that if they happen, they will break my business? They can be even business. And then design the system in a way that, if you can, does not even have those states. And I can give you an example. Very kind of probably, I apologize, it's probably trivial, but just I think it might kind of make the point. So initially, when people were like creating automated meat grinders, they didn't think that they don't want the meat grinder to grind hands. So what they did was that they created this thing that would grind meat for you, but then it would happily grind your hand as well, because you hadn't had that in. But they hadn't thought about it when they were designing the system. Then what they did for a few years, I remember this actually, they added controls, which are like your sensors at the entrance. So what they would do was that, okay, so it would sense if something that looked like a hand, temperature, whatever, they have all this kind of interesting stuff to detect the hand and stop the system from grinding. And the problem, we all know what, it's like the sensors are faulty, they eventually fail, whatever, and so they kept grinding. So what they did was that they got together and thought, okay, so what did we do? We should just rethink the whole thing. They made a small change, which was, okay, do we really need this wide entrance to the meat grinder? Can't be just it's a meat grinder, it's not a meat cutter. So we can ask people to just cut things, smaller piece, and put them so that the hand wouldn't even fit. With that small design, having requirement and the energy requirements, okay, I want meat grinder, I don't want it to grind hand. They built something simple. It doesn't have all those kind of complex technology, sensor, but it would definitely meet the objectives and both requirements and energy. This is the kind of mindset change. It's not very it's not expensive. It's not time consuming. It's just the way that you look at the problem.
I see the challenge here, Mateen, is people that aren't going to have a catalog of anti-requirements. And so I think about like, I know, and I want to get into threat modeling next because I think you've written on threat modeling. So there's got to be a connection to threat modeling in this journey we've been on here. But let's talk about the challenges of teaching people to unlock anti-requirements, because we have the same problem in threat modeling. We use things like Stride, for example, the best possible way to get people started in threat modeling, because you can't expect a developer to look at a diagram and go, yes, there's this problem and this threat and this threat and this threat. We have to give them a mnemonic and let them learn using a simple approach. And then we can give them some more detailed approaches to do it. And then over time, they get to the point where they think like we do as security people, where they're just like, ooh, they just look at something and they see the threats, but we don't get that by default. So how do you get people to see the anti-requirements in the very early times using this new approach?
Yeah. Absolutely. So I think there are two things we are doing, and we have started actually working in. One is in every kind of sector, you can actually have a preset of things that people can can ask themselves from the outset. So when they're just like the requirement stuff, if you're building something in healthcare or in payments or whatever, there are certain things you need to take into consideration. But the problem is that security is very context, again, sensitive. So you can never have a complete set, but you can have a set of things that makes people start thinking in those terms. And usually people are more familiar with their own business, of things they want to achieve, their own sector. They actually, this is based on my experience working with a few kind of programmers, that when you give them some of the kind of entry points of these are kind of things I like to think about, they actually start coming up with more and more and more. And that's actually, this approach has been successful because I've seen it. It's just, they just need that kind of initial push, and then they start thinking those terms, and then they, just like the requirements, they come up with these kind of anti-requirements from the outset. And again, because it's an iterative, just like anything else, it's an iterative process. So you might need to just start with those kind of most important things that come into your head at the beginning, and the next kind of phase, you come up with more, and then you try to, something that can actually build a system with those anti-requirements, and something you need to add controls. And there's, if you can re-engineer, you can go just like something you might need to go re-engineer the whole thing, so that because you just thought about a new anti-requirement. But I think it's really not as kind of difficult as it seems. That's one thing. The other thing is, even if it is, we are spending a lot of money and kind of effort and kind of on security. I think we should shift that towards this. And the reason is that this will be the part that if you kind of spend more time and energy on, it will probably, this is my perspective, based on all the kind of years of thinking about it and research and whatever, this is the part that can actually help us achieve semantic security as an emergent property. Anything else will be syntactic security. We can solve these kind of small vulnerabilities problems here and there, but it cannot give us that holistic kind of security that we're after, or we've been after for many, many years.
So what happens? Here's another $1 million question. I often think about, in the context of threat modeling, when I go in and I start working with a company and I'm like, would have been great if I'd have been here 15 years ago when you started this company. Because then we go through a process of saying, how are we going to retroactively try to threat model the most important assets inside of the application portfolio, knowing full well that we're never going to get to 100% coverage. Whereas if we had started from day one and said, threat modeling is a foundational principle of how we build software here and hardware, and we do threat modeling for everything, there would be a lot smaller delta if I walked in 15 years in the future, right, from when that decision happened. All of that to say, how does this strategy, philosophy, approach that you're describing work in the real world, where people have already, many ships, application and product ships have already sailed, and they're, maybe towards the end of their journey? Like, how can you apply this philosophy retroactively to existing software?
Yeah. So legacy complex software is always a problem. So, and the problem Yeah, I totally acknowledge that. And problem with our kind of discipline is that today's noble idea are tomorrow's legacy, right? So, and the pace is so fast that you can always. So that's why I'm not actually discounting the kind of idea of syntactic security. So one thing that real time, so my focus, I've done other articles talking about what can be kind of automated in DevSecOps. And I think this is, the more we can automate the syntactic security, the more we can spend on semantics. And this is what I'm trying to say. Most of our efforts as kind of external, as a consultant, a security expert, whatever, that when we join a team, is spent still on syntactic security to identify the vulnerabilities, the problems that they should really be, should be written. We should have tooling for them so that we could just easily find them and fix them. So there shouldn't be any real kind of mental energy spent on those kind of things. So it's, in reality, I think we need to spend some, as a discipline, make sure that we have all that part fully automated, so that when we kind of join this kind of new initiative, that already got something, they're already at the end, basic, as I mentioned, the end of the journey. We just apply those tools, identify all the syntactic security matters, make sure that there's nothing syntactic flaws in their systems, and then start talking to them in the meanwhile. Because one thing that I've learned is that unless you understand the business well and the kind of system they're trying to build well, you cannot actually provide them with solutions from the semantic security perspective. And that's why I think we need to schedule these kind of sessions, workshops with them to work on answers, just like what we did with trick comments when we want to kind of build the system. To understand the answer comments, what is absolutely important for them to prevent. As I said before, most of the time, my experience has been, it's possible to find simple tweaks in the system in a way that it automatically prevents those kind of bad, undesirable behavior. Let me give you a very quick example. Most of the problems we have, some of the problems we have is in the authorization mechanism. So it's like, they do have an authorization system. It's not about the technical capability. So if it fits a syntactic issue, for example, if you know that you've implemented your auth to correctly, your Open ID Connect and totally correctly, if you use your crypto libraries that are secure, if you scan your containers, you know that they have no vulnerabilities or anything. So the technical foundation is there. The problem is they don't know who should have access to what, and that is really depends on the context of the business. And this is something that, even if a system is already there, a little bit of kind of understanding and consultancy, understanding the answer requirements, what they want to achieve, what they don't want to achieve, can help configuring their systems in a way that would definitely achieve what they want to achieve. So it's not really, so that if that, the authorization mechanism is syntactic, the authorization policies and rules, in my opinion, are semantics. And these are the kind of things that you need to focus on. That doesn't matter if they're at the end or beginning, whatever. When I started project here, we start with kind of that early on. We start from, okay, what are the policies that we need to implement? Because that it has an impact on the kind of authorization mechanism we want to use as well. So sometimes you don't need this kind of full-fledged attribute-based access control, whatever, because you can have a much cheaper kind of solution that solves that problem. But if it's already happened, there are ways to configure it to your advantage.
So paved roads, the concept of paved roads,
I keep thinking of as well,
play into your approach here, like with authorization. To if security is the absence of vulnerabilities, and we're focused on raising this stack and getting out of the syntactic type of things into the semantic things. Paved roads, like providing an authorization system and library and everything, locks right in step with what you're describing here.
Absolutely. I think we're getting better from that perspective. So we now have like these libraries that are available for people to use. We have like no one you kind of cook up their crypto any longer. So we have like secure crypto libraries that people can use. The containers we have for pre-configured, pretty secure. For syntactic security, I think we're doing a good job generally in security. But the problem is, because the focus of security industry discipline has been on the syntactic security. But the reason we haven't been able to achieve what we wanted to achieve holistically has been neglecting semantics. That's what I'm trying to say. Absolutely, you're absolutely right. So paid paths, paid frameworks, whatever they're called in different kind of parts of the industry. Secure, CDKs, whatever, the things that AWS provides, secure architectural kind of frameworks, all those kind of things are great. We should definitely take advantage of them. They give us syntactic security. Then we need to focus on semantic security. Okay, so now I join your initiative. I need to understand what you're trying to achieve as a business and try to help you to understand your requirements and anti-requirements, and then try to configure these paid framework in a way that achieve what you want to achieve.
All right. Well, I think we gotta move on to our lightning round. But I gotta say, Mateen, this has been a fascinating conversation. My brain is churning away here and processing these concepts and ideas, and I'm still stuck on, is security the absence of vulnerabilities? And like any good philosopher, I don't need to have an answer yet. I'm going to need to ponder it for another 20 years, and then I'll get back to you. Not really, but I'm going to think about that one some more, because I'm not fully bought in on it yet. I'm not saying that you're wrong. I've been defining security so differently for so long that I really have to spend some time pondering it, thinking about it, and seeing if it lands for me after a day and a week and some time in the future. But excellent conversation. Excellent. It's been an excellent topic, but Robert, we're not done yet. We got to take Mateen into the lightning round. So take it away.
All right, Mateen, we have 3 questions that we usually ask. So the first one is, what's your most controversial opinion on application security, and why do you hold this view?
Okay. So I think that's a very interesting question. I think the ball, as Chris mentioned, I think just anti-bombing kind of concept has been quite controversial, and even the systemic security has been controversial. As I mentioned, there's been a lot of objections to the nature of security that I defined it, and I've been talking about it because again, people talking about syntactic security not being necessarily an emergent property because you can identify things in the components and fix them. And again, as an anti-requirement, there've been they've been controversial from 2 perspectives. First of all, it's a new term, and I've specifically used that, a new term to make people stop and think. Because again, to break that thing that I mentioned in the beginning, like familiarity, confusing familiarity with understanding, because they've been used terms that people have heard a lot, they think they understand it, so they don't think about it. So when you talk about threat modeling, resilience, security, just people go, okay, it's like, yeah, of course we know what resilience is. As any engineer, and that's not like a duty and stuff, and of course, where's a part of it is bread and butter, But then when you talk about anti-bombs, everyone says, what? And they start actually thinking and arguing, and which is great. I don't mind. I love that. The conversation. Just like I love to hear from Chris that he finds out that this is not very correct. And that's always been. I've been trying to kind of solve this problem all the time. So initially, I thought that security is just a kind of emergent property, but then I realized actually security probably is not even a property itself. So it's in the absence of something else. So these are kind of things that, as Chris also mentioned, like this constant thing and try to correct yourself or find new ideas that could complement or kind of contradict. And that's the whole thing about science. And it's no religion, right? I'm more than happy to contradict myself next time we talk. Actually, I was completely wrong. So Because this is the beauty of kind of thinking and being able to correct yourself and build, to your stuff.
All right. Next question is, if you could display a single message on a billboard at the RSA or Black Hat conference, what would it say?
I already know what he's going to say, but I'll tell you if I think I know what's going to go on that billboard.
I would say security does not exist. Long live anti-requirement.
Okay. That's not what I thought. I was expecting you to put security as the absence of vulnerabilities, but security does not exist. That feels like we're in the Matrix all of a sudden. Like,
Right.
Yeah. Because again, as I was talking about, security at the moment at least, but my understanding is that security does not exist as an independent kind of phenomenon. So it's an absent existence. That's why I'm saying security does not exist. And then it's independently.
Okay. All right. And the last one is, what's your top book recommendation and why do you find it valuable?
Well, I generally like, this is not really a security book, but I've learned a lot about it. So generally, there are two any book that is about systems thinking, I really think people grab and can read. There are many of them at the moment. And I don't really want to kind of recommend one. So if you just look on Amazon and search for systems thinking, you can find a lot. And the books that they've written by Russell, Ackoff, I really like. And his these are all in systems thinking, and his kind of student Mehdi Karachadobi. Again, it's a little difficult too. So his name is Persian, so it's difficult to search. But you can definitely find them if you just search for Russell Ackoff's student book, something like that. You can find that. And I very like Nassim Taleb's kind of books, like Black Swan and Skin in the Game, Randomness. What was the name exactly? I don't remember exactly what all his books are. I think really, really interesting. I really enjoy. I've read most of them a couple of times actually, and each time I read them. Oh, Anti-Fragile was also very, very interesting. So, I read it a couple of times. It's just, you can learn a lot from them. And they're not directly about security, but I think they're very, very relevant.
Yeah, I agree. I've read some of Taleb's books, and they're just so dense. Like you have to stop and think about. Like you can't read them quickly. You kind of have to read some, then you have to spend some time processing it away from the book. It's so strange. Like very seldom do I have that experience with an author where normally I read pretty quickly and I just kind of blow through things. But with him, I'm like, wait, what? Sometimes I got to go back and read the paragraph 2 more times to be like, what? What are we talking about? Yeah, okay. Got to ponder that for a while. All right, Mateen, what would be your key takeaway for our audience here?
Well, I think the most important message I'd like to share with everyone is that start thinking about the anti-requirements from the outset. The things that you don't want your system to realize. When you're thinking about the requirements, do not ignore them. Do not leave them to later, because it will get more and more expensive as you kind of as time goes by, and to fix the problems that are caused by anti-requirements. So whatever you want to call them, undesirable behaviors, security requirement, whatever they're all, start thinking about them from the outset. And that's the message I'd like to show.
Excellent. Mateen, thank you for sharing these concepts, this knowledge, this wisdom with us. Like I said, you've given me plenty to ponder. So I'll be doing that over the coming weeks, thinking about all of these things. Sounds like you need to write a book.
Yes.
And put all this stuff down into a book so that people can digest it. Try to make it like a Taleb book where it's so dense that people have to read a page and then go sit in the woods for a while and stare up into the sky and ponder the content. But no, for real, you should write this down. You should put it in a book and and systematize this whole thing in such a way that people could understand it. Because there's a lot of new stuff here. There's a lot of you're challenging our thinking on something as core as what is security, which people are going to need to digest that and to kind of come around to it. So, but yeah, thanks for taking the time to be with us. It was an excellent time. I look forward to a future chat where we can talk about something else philosophical about.
Thank you very much. We enjoyed our conversation.
Thank you.
Thank you.